A lot of questions about this homework question right here. Calculate, or and homework questions like this, calculate the solubility of lead carbonate in pure water and in a 0.002 molar solution of lead nitrate. The big thing I think many people are overlooking is that they are not looking for the concentration in molarity. They are looking for the concentration in grams per liter, not moles per liter. So there's actually one extra step that we need to go through there. And so to get us started, the first thing we need is the KSP of lead carbonate, which is 7.40 times 10 to the minus 14. And the other piece of information that we need to answer this question is that the molar mass of lead carbonate is 267.21 grams per mole, and we'll need that at the end. So lead carbonate is going to ionize into a lead 2 plus and a carbonate, CO3 2 minus. So my KSP would equal concentration of lead times the concentration of carbonate. When we set this up, I don't know lead, I don't know carbonate, but they should be equal to each other, 1 to 1. So my KSP of 7.4 times 10 to the minus 14 equals x times x, right? That equals my x squared. So I can just say x squared. Take the square root of both sides to see that x, which is my concentration of lead in solution and therefore my solubility of lead carbonate, to be 2.72 times 10 to the minus 7 molar. We know molarity is moles per liter. We are looking for that information not in moles per liter, but grams per liter. So to find the actual answer they're looking for, we need to say, okay, for every 1 mole, I need to bring in the molar mass. I need 267.21 grams of this. Multiply by the molar mass, and I get a solubility of 7.3 times 10 to the minus 5 grams per liter. And that's just for pure water. The next one, we have a common ion in solution, and so the calculation is going to be a little bit different because we need to take into consideration this strong electrolyte, 0.002 molar lead nitrate. We can set up the same KSP, right? We know KSP equals my concentration of lead, my concentration times my concentration of carbonate. The only difference here is 7.4 times 10 to the minus 14. My concentration of lead, I know that is 0.002, and that is from my strong electrolyte, lead nitrate. I don't know carbonate, that's my X. Divide both sides by 0.002. So that cancels out. And I get a concentration of carbonate, which would tell me the solubility of lead carbonate under these conditions of approximately 3.7 times 10 to the minus 11 molar, which is moles per liter. So the same final last step for every 1 mole, 267.21 grams of this. So we multiply, and the solubility in the presence of the common ion, I get a concentration or a solubility of 9.9 times 10 to the minus 9 grams per liter. So 9.9 times 10 to the minus 9 here, and 7.3 times 10 to the minus 5 here. So just pay attention to what they're asking for. I think many of you are solving, getting X, and then just trying to put molarity in here. when it's not asking for molarity, it's asking for grams per liter. So we need to take into consideration the molar mass to convert molarity, which is moles per liter, into grams per liter. All right, moles cancels out, and we're left with grams per liter.